to my channel again. Today I am going to discuss some important problems in complex number. Let us take one of them. If Z1 and Z2 be any two complex numbers such that mod Z1 is equal to mod Z2 and argument Z1 plus argument Z2 is equal to pi, then prove that Z1 is equal to Z2 conjugate. Z1 is equal to minus of Z2 conjugate. This is the question which we have to prove. So see, Z1 and Z2 are two complex numbers. So let us take, let Z1 is equal to x1 plus iota y1 and Z2 is equal to x2 plus iota y2. Since mod Z1 is equal to mod Z2, therefore x1 square plus y1 square whole under root will be equal to x2 square plus y2 square whole under root, which will be x1 square plus y1 square is equal to x2 square plus y2 square, or call this relation 1. Now come to the second, that is argument of Z1 plus argument of Z2 is equal to pi. So argument of Z1 is nothing but tan inverse y1 by x1 and argument of Z2 is tan inverse y2 by x2 is equal to pi. Now we are using the formula of tan inverse A plus tan inverse B, and the formula is tan inverse A plus B whole divided by 1 minus A into B is equal to pi. This implies to x1 y2 plus y1 x2 divided by x1 x2 minus y1 y2. I have taken the LCM and x1 x2 is cancelled from both numerator and denominator. This tan inverse becomes tan on the second side, tan pi. So let us move to the next step. I am erasing the question. This implies x1 y2 plus y1 x2 by x1 x2 minus y1 y2, and the value of tan pi is nothing but 0. It means x1 y2 plus y1 x2 is equal to 0. Call it the relation number 2. So students, the equation 2 will be x1 y2 plus y1 x2 is equal to 0. This can be written as x1 y2 is equal to minus y1 x2, or x1 by x2 is equal to y1 by y2. This x2 comes on divide on left side and y2 goes on divide in RHS. So minus x1 by x2 is equal to y1 by y2. Suppose is equal to k. Therefore x1 is equal to minus kx2 and y1 is equal to ky2. Now let us see the equation 1. What was the equation 1? Equation 1 was x1 square plus y1 square is equal to x2 square plus y square. Now put the values of x1 and y1. So it will be minus k x2 whole square plus k y2 whole square is equal to x2 square plus y2 square. Clearly k square is common and we have left with x2 square plus y2 square is equal to x2 square plus y2 square. These two cancel out from both sides, which gives k square is equal to 1. That is, k is equal to 1. The square root of 1 is also 1. So what will be the value of x? X is equal to minus k x2 and the value of k is 1, so it is minus x2, and y1 is k y2, again put k is equal to 1, so it is y2. Getting up to this step, now comes to the proof. Z1 is equal to x1 plus iota y1. The value of x1 is minus x2 and value of y1 is y2. Take minus common, then it will be x2 minus iota y2. Clearly you can understand that x2 minus iota y2 is nothing but the conjugate of z2, because z2 was x2 plus iota y2. So after taking the conjugate of z2, this sign becomes negative, this one. So we have proved that z1 is equal to minus conjugate of z2. I think you have understand the concept what we are using here. Now come to the next question. Start one more question that is important for you. If z is equal to tan alpha minus iota, find its polar form. Means we have to convert this number into polar form. See students, here z is equal to tan alpha minus iota, and we all know that tan alpha is not defined when alpha is an odd multiple of pi by 2. Means clearly it will be defined for alpha not equal to 2n minus 1 pi by 2. मतलब अल्फा का कोई भी वैल्यू अगर पाई बाई 2 के ऑड मल्टीपल में होगा तो tan 90 डिग्री इन्फिनिटी हो जाता है, ये नॉट डिफाइंड हो जाएगा। इसका मतलब हुआ कि z इज इक्वल टू tan अल्फा माइनस आयोटा में अल्फा का मान कभी भी पाई बाई 2 या उसके ऑड मल्टीपल के बराबर नहीं हो सकता। ऑल्सो वी नो दैट tan pi plus alpha is equal to tan alpha. It means pi is the period of tan. After each pi angle, tan is repeated. So pi is the period of tan alpha. So we take alpha as alpha belongs to 0 to pi by 2. Pi by 2 is not included, so exclude it. Union pi by 2 to pi. So in this complex number z is equal to tan alpha minus iota, first of all it is necessary to know what should be the value of alpha, and clearly we conclude that alpha should be 0 to pi by 2 union pi by 2 to pi. Now take case 1. Case 1, that is when alpha belongs to 0 to pi by 2. In that situation, tan alpha is positive because in first quadrant tan is always positive, and iota, that is the value of y, is -1, minus iota. So x is positive, means real part is positive and imaginary part is negative. That is, real z is positive and imaginary z is negative. So x is positive, y is negative. It means it is the fourth quadrant. So z lies in fourth quadrant by seeing the negative value of imaginary part and positive value of real part. So after concluding that z lies in fourth quadrant, let us try to find the argument of this complex number. So I am going to erase it. I think you have understood all these theories. So to convert into polar form, first of all we have to find the value of r. And what is r? R is nothing but mod z. So it will be tan square alpha plus 1, x and y. It will be sec square alpha under root. So plus minus sec alpha is the value of mod z. Now try to find theta. Theta is tan inverse mod y by x. So tan inverse, the value of y is -1, x is tan alpha. It will be tan inverse cot alpha, and cot alpha can be written as tan pi by 2 minus alpha. So now tan inverse and tan cancel. It is pi by 2 minus alpha. It is the value of theta. But since we have seen that this z lies in fourth quadrant, since z is in fourth quadrant, therefore argument of z will be minus theta, that is minus pi by 2 minus alpha, which will gives you alpha minus pi by 2. So I am going to erase the upper side. Therefore, in polar form, z is equal to r cos theta plus iota sin theta. So the value of r is sec alpha. We are taking here the positive value because alpha lies in first quadrant here. Cos the value of theta, it is argument z, that is alpha minus pi by 2. So cos alpha minus pi by 2 plus iota sin alpha minus pi by 2. So this is the value in polar form when alpha lies in first quadrant. Again I am going to erase it. Now we will discuss upon second case. Case 2, that is alpha belongs to pi by 2 to pi. Clearly, if alpha is in second quadrant, then the value of tan alpha is negative. So in the complex number z is equal to tan alpha minus iota, tan alpha is going to be negative and it is also negative. Both are negative. So z lies in third quadrant. So I am writing here, therefore Z lies in third quadrant. So let us try to find the argument of Z. In third quadrant, the argument is pi plus tan inverse mod y by x. It will be pi plus tan inverse. Clearly the value of y is -1 and x is tan alpha. So 1 by tan alpha. I am writing one more. Clearly it is cot alpha. But my dear student, here we are seeing that alpha lies in pi by 2 to pi, second quadrant. So the value of cot alpha is negative, minus cot alpha. It will be pi plus tan inverse, and minus cot alpha means minus tan pi by 2 minus alpha. This will be pi plus tan inverse, and minus tan theta is equal to tan minus theta. So minus should be multiplied with the angle. Then we have left with pi by 2 minus alpha becomes alpha minus pi by 2. Now tan inverse and tan cancel. We have left with pi plus alpha minus pi by 2. That is pi by 2 plus alpha. Therefore, in polar form, it will be the value of r is minus sec alpha in second quadrant. Cos theta, that is argument. The value of argument is pi by 2 plus alpha. So cos pi by 2 plus alpha plus iota sin pi by 2 plus alpha. So this is the आंसर. तो हम देख सकते हैं दोनों ही केस में पोलर फॉर्म का वैल्यू अलग अलग आया, क्योंकि दोनों ही केस में एंगल अलग अलग आ रहा है और tan अल्फा का वैल्यू भी पॉजिटिव और नेगेटिव चेंज हो रहा है. ठीक है दोस्तों, चलिए हम देखते हैं नेक्स्ट क्वेश्चन. लेट अस सी वन मोर क्वेश्चन. इफ a is equal to cos theta plus iota sin theta, find 1 plus a by 1 minus a. We have to find the value of this expression if a is this one. Now 1 plus a by 1 minus a is equal to 1 plus cos theta plus iota sin theta by 1 minus cos theta minus iota sin theta. Take 1 plus cos theta as one term plus iota sin theta, and in denominator it is 1 minus cos theta minus iota sin theta. I think you all have remembering the formula that 1 plus cos theta is nothing but 2 cos square theta by 2, and sin theta is nothing but 2 sin theta by 2 cos theta by 2. Check the denominator. 1 minus cos theta is 2 sin square theta by 2 minus iota. Again it is sin theta, so 2 sin theta by 2 cos theta by 2. Clearly in numerator 2 cos theta by 2 is common, then we have left with cos theta by 2 plus iota sin theta by 2, and in denominator I am taking the common minus iota into 2 sin theta by 2. So see first this term, minus iota into 2 sin theta by 2 is common, so we have left with cos theta by 2. and here 2 is common, sin theta by 2 is common, but minus I is not there. So it will be 1 by minus iota sin theta by 2. Clear? Here iota is not there, so iota should be in divide. Now dear student, very easily you can see that 2 cancel, cos by sine is cot, and 1 by iota. We all remembering the formula that 1 by iota is nothing but minus iota. So it comes to be minus iota and minus plus iota, cos theta by sin theta by 2, cot theta by 2, and here it is cos theta by 2 plus iota sin theta by 2 whole divided by cos theta by 2. Again it is plus iota, so plus iota sin theta by 2 cancelled, and simply we have left with iota cot theta by 2 is your answer. Okay, so let us move towards the next question. The next question, students, if 1 plus iota whole to the power 2n is equal to 1 minus iota whole to the power 2n, find the smallest possible integral value of n. This is the question. So let us try to solve this one. Since 1 plus iota whole to the power 2n is equal to 1 minus iota whole to the power 2n, it can be written as 1 plus iota whole square whole to the power n and 1 minus iota whole square whole to the power n. On squaring, it is a square plus b square. Iota square is minus 1 plus 2ab whole to the power n, and here a square plus b square minus 2ab. 1 cancel, 1 cancel, so we have left with 2 to the power n into iota to the power n, and on right side it is minus 1 to the power n into 2 to the power n into iota to the power n. Now student, 2 to the power n and iota to the power n should be cancelled from both sides. Then we have left with 1 is equal to minus 1 to the power n. So we all know that for the even value of n, minus 1 raised to power any even number is equal to 1. Therefore, least value of n is equal to 2 to hold this identity. So this is the answer, n is equal to 2. I think you have understood this step. Minus 2 iota, so minus 1 to the power n, 2 to the power n, and iota to the power n is here. 2 to the power n, iota to the power n is cancelled out from both sides. 1 is equal to minus 1 to the power n. So what should be the smallest value of n? It should be n is equal to 2. Thank you. Let us move towards one more question. Today, the questions that you are seeing all are important for various competitive examination related to engineering. So now let us move to one more question in this line. The question is, solve the system of equations given by real z square is equal to 0 and mod z is equal to 2. So how to solve it? First of all, choose the number z. Let z is equal to x plus iota y. Now you have to find the mod z. It will be under root x square plus y square, but the value of mod z is given as 2. So after squaring, we can conclude that x square plus y square is equal to 4. Call this relation as relation number 1. Now come to this part, z square. For that, first of all, we have to square it. Z square is equal to x plus iota y whole square. It will be z square is equal to x square plus iota square y square. Iota square is -1, so it is minus y square plus 2ab. So iota 2xy. This is the value of z square. Therefore, what should be the value of real z square? Means we have to write only the real values. So real value of z square is nothing but x square minus y square. And according to question, real z square is given as 0. So x square minus y square is equal to 0. This is the relation number 2. So after obtaining these two relations, we have to solve these relations to find x and y. So I am doing here. Equation 1 plus equation 2 gives us, equation 1 was x square plus y square is equal to 4, and 2 is x square minus y square is equal to 0. On adding y square cancel, 2x square is equal to 4, so x square is equal to 2. So what should be the value of x? It means x is equal to plus minus root 2. Now try to find the value of y. So from equation 2, x square minus y square is equal to 0. It gives y square is equal to x square, or y is equal to plus minus x on taking the square root, but y is plus minus root 2. So we get the different values of y. Plus root 2, plus minus root 2, minus plus minus root 2, and minus plus. So plus minus root 2 is the value of y. So x and y both comes to be plus minus root 2. Therefore, z is equal to x plus iota y will be plus minus root 2 plus iota plus minus root 2. Plus minus root 2 is common, then we have left with 1 plus iota. So this is the answer. So let us move towards our next question, that is find real value of theta if 1 plus iota cos theta by 1 minus 2 iota cos theta is real. So first of all I am going to solve this. 1 plus iota cos theta by 1 minus 2 iota cos theta. Let us take this number as z, and now we multiply the numerator and denominator by the conjugate. So 1 plus 2 iota cos theta divided by 1 plus 2 iota cos theta. In numerator it is 1 plus 2 iota cos theta plus iota cos theta plus iota square, 2 iota square, and cos square theta. So 2 iota square cos square theta, and in denominator it will be a minus b a plus b, so a square minus b square. Clearly it will be 1 plus 2 iota cos theta plus iota cos theta is 3 iota cos theta, and here iota square is -1, so minus 2 cos square theta whole divided by 1 minus, for iota square it becomes plus 4 cos square theta. Separate it as real and imaginary. So 1 minus 2 cos square theta with the real part plus iota 3 cos theta, and 1 plus 4 cos square theta can be separated with both. तो स्टूडेंट आप देख सकते हो कि इस कॉम्प्लेक्स नंबर को कॉन्जुगेट से मल्टीप्लाई करके रियल पार्ट और इमेजिनरी पार्ट में चेंज कर दिया गया है। जैसा कि क्वेश्चन में आप देख सकते हैं, गिवन है कि दिस नंबर इज रियल, इट मीन्स द इमेजिनरी पार्ट इज जीरो। इफ द नंबर इज रियल मीन्स व्हाट? रियल पार्ट इज देयर बट इमेजिनरी पार्ट शुड नॉट बी देयर। Since Z is, so now student you can see that this number is real, means Z is real, therefore its imaginary part will be 0. So 3 cos theta by 1 plus 4 cos square theta must be 0. It will gives you cos theta is equal to 0, and we all know that the value of cos is 0 when theta is a multiple of pi by 2, odd multiple of pi by 2. So the general solution will be theta is equal to 2n plus 1 pi by 2, where n is, or where n belongs to integers. I am writing n is any integer. So for all integer value, this one is odd, and odd into pi by 2. So everywhere cos theta is 0. So this is the answer. Theta is equal to 12 plus 1 pi by 2. Getting? Okay. So student, in today's class, we have learned upon various questions. So at last, I am going to take one more, the last one. So let us move to the last question of complex number, that is, find the modulus and amplitude of e to the power 3 minus iota pi by 4 whole to the power 3. Before getting to this question, you have to know one more thing, that a complex number in Euler's form is Z is equal to R e to the power I theta. This is the formula of complex number in Euler's form, where R is nothing but modulus Z and theta is nothing but argument of Z. After knowing this new formula, let us move to this question. Here one more thing I am going to state, that e to the power I theta is nothing but cos theta plus iota sin theta. So after knowing these facts, let us start with the question. Here Z is equal to e to the power 3 minus iota pi by 4 and whole to the power 3. Very clearly you can conclude it that it is e to the power 9 minus iota into 3 pi by 4. This can be written as e to the power 9 into e to the power iota and minus 3 pi by 4. Compare this relation with the relation in Euler's form, that is R into e to the power I theta. We conclude that the value of R, that is modulus Z, is nothing but e to the power 9, and value of theta, that is argument Z, is nothing but minus 3 pi by 4. So minus 3 pi by 4 is the argument and e to the power 9 is the modulus. So now we have concluded to the topic complex number. From next video you will see my topics, my explanation upon trigonometry. So thank you for watching. Don't forget to like and subscribe to my channel, and also forward the link of my channel to various students. Thank you for watching.